to my channel. It's Laura here, and I'll be taking you through General Arithmetics Chapter 3. Okay, so for the first two videos, if you've got any comments, any questions or additions, you can just type in the comment section and I'll answer to it. Okay, so today I'm gonna focus on fractions while we're doing arithmetics. Okay, so our question reads: an ice cream will cost $40. Jane has $40 and buys as many ice creams as possible. Find A, the number of ice creams she bought. B, the change she receives. Okay, so let's write solution. Okay, so for the number of ice creams she bought, we're going to say Jane has $40. Okay, and an ice cream costs $40. Okay, so now for us to calculate the number of ice creams she bought, we have to divide $40 into $40 so that you can see how many ice creams she bought costing in the $40. Okay, so we're going to say number of ice creams bought is equal to $40 divided by $40. Okay, so our situations don't change. We are going to multiply here by 100, multiply by 100 to convert our dollars to cents, right? As we know, $1 is equals to 100 cents. So if you multiply by 100, you get 4,000 over 240. We divide 4 into 24 is 6. 4 into 4 is 1. 4 into 7 is 7. Then we now divide 6 into 100. Okay, I'll come here. It's equals to 100 over 6. Remember, these are now in cells. 6 into 6, 1. If we cancel out, we don't have to pay 6 into 6, 1. 6 into 10, it's 106. 6 into 10 is 104. 6 into 40 is 6.4. 6 into 40 again is 6.4. And as you can see, it's a recurring decimal. So you're going to say 16.66 recurring. But for us, we cannot obtain 16.66 recurring ice cream. So it's going to be round up 70 ice creams. We are going to round below because this is given by 16 ice creams. So here we round below 16 given by 16 ice creams. Okay. Having completed that part, we are going now to focus on B. and B replaces the change she receives. So our solution, I'm going to say the change she receives, that's B. I'm going to say $2.40 times the number of ice creams bought, the number of ice creams bought, yes, 0 here, 0, 4, 2, 0 here, 4, we'll carry 6 by 2, 12, 14, we add 0, 4, 8, 3. So we add the number, we count the number of decimal places, 1, 2, so it's $38.40. That's what the cost for the 16 ice creams. So for us to obtain the change she receives, you're going to say $40 minus 38.40. Okay, let me just write it here. 38.40. Okay, you get 0, 6, get 9 here, 4 here. This is, so their change was $60. Okay, that's it for question 12. Now on question 16. So what's happening is actually skipping all the other examples that have got the other questions that have the same working you would have done. So what I will do is I will definitely put the questions in this video and you work them out, and if you have any query you ask me on how it's done. Okay, so I'm going on question 16 and it's now on significant figures. Okay, so the first question is express a 1.269 to 3 significant figures. So our solution, is 1.1269 to 3 significant figures. One 1,269 to 3 significant figures. 1, 2, 6, 9. We are going to read from our left hand. So you can say 1, 2, 3. So it's both here. And since the number that follows is above 5, these are they are tens. So this is above 5. So it changes to this one, right? 1, 2, 7, 0. These are now 3 significant figures. For part B, 3.1017. So I'll count it from the left hand side and say 1, 2, 3. This is our third significant figure. And we check whether the value that would be here would be above 5 or below 5. So this is above 5, so it changes this one to 3.02. Okay, our part C, we're going to say 0.03201. 2, 3 significant figures. Okay, for this part, the first 0 is not counted as a significant figure. Neither is the second 0 counted as it. If there is a range of zeros here, before we reach an actual figure, a significant figure, we ignore them. So here we're going to start counting our numbers from this value. So let's say 1, 2, 3. So here this 0 is now our significant figure, since it is within other numbers. But if it's either outside the side or outside the side, we do not count them. Okay, so it's 1, 2, 3, and we check the following number, that is it above 5 or below 5. If it's below 5, then there's no change to our 0, but if it's above 5, then there's a change to our 0. But in our case, it's below 5, then there's no change to our 0. So this becomes our answer and we cancel out everything that comes there. Okay, and be sure to put the 0 here, it's really important. State the number of significant figures in each of the following: 0.029 centimeters, 8.04 grams, 2,800 kilometers. So you have to state the number of significant figures. So for A, we said for significant figures, we do not count the zeros that are at this side or at this side. So for this part, our number of significant figures just 1, 2. So I'm going to say 0.029 centimeters is equals to, we count the number of significant. We start here, we leave these 2. If there were zeros at this time, we were also going to leave those 2, those zeros. So you just have 2 and 9. So here is 2 significant. This is the number of significant figures that we have. For B, 8.04. So for those that have got, figures that have got 8.04 and you've got a 0 inside the other significant figures, we consider that 0 as a significant figure. So for number of significant figures here is 1, 2, 3. Okay, so for our C, it's 2,800 kilometers. Here, as I've said, the zeros that will be here or the zeros that will be after the significant figures. What do you mean by significant? I mean those numbers that are from 1 to 9. Okay? Those are the only numbers that I refer to as significant figures. Okay, so for this part it's 1, 2. The rest are not counted as significant figures. As I've said, I will put other questions. Then once I put this just to show you direct to our start, I will put other questions and you have to practice with those. And when you do it, now we are on HCF. So our question is find the HCF of the following. So for part A, to calculate the HCF of each of these ones, and also we find the common factor for all these numbers that we are given. We're going to say 36. You draw your table like this. You find your first prime number. So 1 is not a prime number. So I'm going to start at 2. 2 into 3 is 1. 2 into 16 it's 8. Okay? We go again with 2. 2 into 18 it's 9. Now we put 3. We just find a prime factor that goes into the values. 3 into 9. 3 into 9 is 3. 3 into 3 is 1. So these are the factors of. You find your first prime number. So 1 is not a prime number. So I'm going to start at 2. 2 into 3 is 1. 2 into 16 is 8. Okay? We go again with 2. 2 into 80, it's 9. Now we put 3. We find we just find a prime factor that goes into the values. 3 into 9. 3 into 9 is 3. 3 into 3 is 1. So these are the factors of. So for 36, it's going to be 2 times 2 times 3 times 3. Okay? Now we go from 54. We do the same, we leave out 1. Start with 2. 2 into 5 is 2. Make a 1. 2 into 14 is 7. 2 doesn't go into, we'll go for 3. 3 into 27 is 9. 3 into 9 is 3. 3 into 3 is 1. Okay? Move on to 66. 2 into 60 is 30. 2 into 30 is 15. 3 into 15 is 5. 5 is 1. Okay, so for this part it's going to be 54 is equal to 2 by 3 by 3 by 3. Okay, so for 60 it's gonna be 60 is equal to 2 by 2 by 3 by 5. Now, for us to find the highest common factor in all these numbers, the highest common factor, what would be the highest common factor? The common factor is to appear in both these. Okay, so we are going to say take 2 to appears in both times. Take 3 appears again. Just take them once. Then 5 doesn't appear in all. So our highest common factor is 6. That's how it's done. That's just how it's done. As simple as that. Now for our part B, as you can see, it's very simple. Just have to see and do other examples so that you will be lost. Okay, so we have 216 and 168. We're going to say 216. So our table again. Set with 2. 2 into 2 is 1. 2 into 1 is 7. 2 into 16 is 8. 2 into 1 is 10. 2 into 10 is 5. 2 into 8 is 2 into 5 is 2 into So for our 168, okay, actually, it's off. Now, okay, another point that is important to trace out before we calculate our HCF is for you to obtain the HCF for this part. You have to arrange your work in kind of order so that it won't make it makes it won't be difficult. So you're going to take the first part 2's, you just take 2 times the second part 2 times 2 again times the second part 2 times 2 times the second part 3. They have to be common. But now the third part is 7 and 3, so it can. So these are our values in our answers: 2 by 2, 4, 8, 8 by 3, 24. So this is the answer. Okay, so that's it. Don't forget, I'll stress out this point. You have to write down your common factors in multiples as they go. Your common factors, and you write your common factors. And you align them, taking part by part. And for this part, you leave out because they do not match. Okay. Okay, question 24, please. Find the LCM of the following 12, 15, 18. Okay, so we're going to tackle that. Solution. For A, we're going to take the table. We divide 2 into 12, 6, 2 into 6, 3 by 3, it's 1. We go for the next one. So here, the index, we put it in index, not index, it's actually not. Or index form means whatever we want. Then take 2 squared times 3 for next 15. 2 cannot get into 15, we say 3, but we're not giving the remaining. 3 and 15 is 5, 1. So now you put your 15 is equal to 3 times 5. And now for 18, go 18. You see 2 into 18, 9, 3, 3, 3, 1. Now write it down. 18 is equals to 2 times 3 by 2. Okay, now for LCM. Okay. Now for LCM, for all the values that are within, if you have to find the LCM of 12, 15, and 18, all the multiples that you obtain should be found. All the multiples, all the values that you obtain should be a multiple. A multiple for 12, any multiple of 12 should contain 2 and 3, and any multiple of 15 should contain 3 and 5, and any multiple of 18 should contain 2 and 3. So if we have to find a multiple of that would include 12, 15, and 18, there has to include all the values. That's what the difference with the HCF. With the HCF, we just find the common factors that appear in both the values that we would be given. But for LCM, we just have to find the multiple, okay, that has all the multiples involved. So for LCM, we're going to say LCM of 12, 15, and 18. It's gonna involve 2. and we take the highest for each part. It will be the highest, we take the highest multiple for each part, the highest factor, although it has to give us the lowest common multiple. So for this part, you see we have 2 squared, it's not 2, and we just have 2 to the power 1. Which one do we take? We take 2 squared. But if it was for, okay, let me just see. We take to the times. For 3 here, 3 here, 3 squared. We take the number, the factor that will be given with its highest power. Okay? So this is now 3 squared times. We only have 5. But we also have to take 5. Even though it's not fun, but you have to take also 5. So it will be, our answer will be like this. And we obtain. What do we obtain? LCM here, 2 squared is 4, 3 squared is 9 times 5, 54, 180. Okay, so this would be our final answer. Okay, so this is how the LCM is done. Okay, let's do the part B. Part B. We do the same situations. 36, 45, 60. Two into 3, 1, 2 into 6, 8, 2, 9, 3, 3, 1. 2 cannot get into that with the remainder 3. 1, 5, 3, 5, 1. 2, 30, 2, 15, 3, 5, 1. Now we put it in the index form. 2 squared times 3 times 5. For this one, it would be 45 is equals to 2 times 3 times 5. For this one, it's going to be 36 is equals to 2 squared times 3 squared. Now, for us to obtain the HCF of these 3, the LCM, we take the values with the highest common multiples. 2 squared, 2, 2 squared, the highest is 2 squared. With the highest powers, 3 squared, 3, 3 squared. Then 5, we just take 5 because that's the highest to the power 1. What do we get for this one? We also obtain 180. We're going to write our solution. There is an NB that you have to note here. It says NB. Any positive number can be expressed in the form A to the 10 to the n. Let me say any positive number can be expressed in the form A times 10 to the power n, where n is a positive or negative integer. What do we mean by this? It's an integer int a, any number. This is a equal to int between 1 less or equal to a less than 10. Okay. So what do we mean by this note? We are saying any positive number can be expressed in the form a to the a times 10 to the power n, where a is a positive integer or negative integer. And second part says a is any number between 1 and 10. Okay, so for our part A, for solving part A, 650, we were asked to put it in standard form. Okay, so for our A, it has to be within the range 1 and 10. Okay, so this one is going to be 6. The one that will only give us the range which is within 1 and 10 is if this one changes to 6.5 times, not 0.65 or 65. 65. So times. So if we put our comma here, it means we have moved 1, 2. And this area is going to be 10 to the power 2. And it's a positive 2. What are we saying? Any positive number can be expressed in the form. So this is our positive number that we are expressing in the form a times 10 to the power n, where a, this is our a, times 10 to the power n. Our n is constituted for this scenario, where n is a positive or negative integer. N can be either positive or negative, okay? And a is any number between 1 greater or less or equal to a, less or equal to 10. Okay, so meaning that our 6.5, our 650 has to have an a which is within 1. This only means we have 1, 2, 3, 4, 5, 6, 7, 8, 9.
This internet connection isn't reliable at the moment.
Okay, so this is how it's going to be. Okay. 6.5 times 10 to the power 2. So this is our first part. Then for our part B, it's gonna be 37,000. And we also follow the same rules. It's equal to, for this part it's gonna be, we have to have our A within the range 1 to 9. So the range 1 to 9 for this partition will just give us 3.7. So it's gonna be 1, 2, 3, 4. This is 3.7 and it's within the range 1 to 9, 1 to 10. So it's gonna be 3.7 times 10 to the power 1, 2, 3, 4 to the power 4. And this one is very sure positive. Okay. Okay. Wow. Voila. Okay, so for a simple question like this, our n still remains. We are saying a times 10 to the n, where 1 is less than a, less than 10. Okay, so for our solution, it's going to be 0.526, 0.006, that's a. For this part, please follow the steps I outlined for you. These are the ones that gives you this. Yes, we are in ordinary level. That's what they require, but as you move up to A level, those steps won't be required anymore. Okay, so for 0.526, we are saying 0.526. We are saying these 5.26 2 over 10. Okay? And this is the same as 5.26 times 1 over 10 to the power 1. Okay, I'm just following the steps, guys. I've moved my comma, the one decimal place. But this thing is the same as this. This is the same as this. And this also means 5.26 times 10. If we invert this one, it's gonna be minus 1. Okay, guys. So, as I've said, someone might ask me, why did we move one decimal place here? Why did we put over 10 here? Why did we invert? Okay, guys, this is what is happening. We said for our A to be in the range 1 to 10, right? So if we move like 2 decimal places, like 1, 2, it becomes 52. It's no longer within our range. Or if we leave it like this, it's 0 point, of which is 2 would be no longer within our range. So we need a number that will fit our range. That's 5.26 over 10. So that if we divide again, it reduces to this. And here we see 5.26 times 10, 1 over 10 is the same as 5. Is equals to 5.26 times 10. Here we've just inverted. If you invert something which is below and it goes up, it becomes a negative. Okay, that's how it is. So this would be our answer. For my part B, I hope no one is being left behind. 0.00309. Here we do the same move. We have to let our A be in the range 1 to 10. 1, 2, 3. So it's gonna be 3.09 over 1,000. Okay, that's it. Then we say 3.09 times 1 over 1,000. Please, we are still following the same rules. But for now, we can change this. We want it in standard form, that's the tens. So for this part, instead of saying the 1,000, we can put how many tens are into the 1,000? That's 10 to the power 3. Okay? So it's gonna be 3.09 times 10 to the solution. For the first one, we're going to write as it is 9.6 times 10 to the power 5. Okay? Divided by 3 times 10 to the power 3. Okay? So this is how it is. For this part, same. Is also equal to same. It's also correct to say 10 to the power 5 over 3 over 10 to the power 2. Then we simplify, guys. Then we simplify 3 into 3, 1, 3 into 9, 3 into 6, 2, this is 3.2. Times 10. If we say into 16, we're going to bring to the 10 to the power 2. For this part, it's much simpler if we should say this will give you percent 10 to the power 5 minus 2. That's the sum. The sum base, we can subtract 3.2 times 10 to the power 2. Okay? For our part B, 1.2 times 10 to the power 9 over 3 times 10 minus 5 is equal to 1.2 times 10 to the power 9 over 10 to the negative 5 over 3. We simplify 3, 1, 3, 0, comma. 3 into 12, 6. 3 into 12, 4, right? 3 into 12, 4. So this part gives us 0.4 times. For this part, as I said, just find somewhere 10 to the power 9 minus, since it's division, minus 5. This is how it's gonna be. So it's gonna be 10 to the power 14. If you add this, it's gonna give you 14. Or you can just say, since it's below, it can be 10 to the power 9. If you put this up, 10 to the power 5 is put this up, it becomes that. Just saves you the trouble. So this would be our final answer. Simple reads, express the first quantity as a percentage of the second. Express the first quantity as a percentage of the second. So we're going to say solution. We're going to write our solution. Okay? And for part A, express the first quantity as a percentage of the second. So it's going to be $26 over 200 times 100%. I know. Okay. So this is how it's going to be, right? So we simplify 2 into 2, 1, 2 into 6, check here. 2 into 1, 2 into 6 is 3 times this one. 18%, guys. Okay. For your part B, for this part, 1.2 liters of 6 liters is going to be 1.2 L of 6L times 100%. Okay. We simplify and cancel. This cancels out each other. 6.1, 6 into 1 is 0. 6 into 12 it's 2. That's 0.2 times 100%. 0.2 times 100%. When I change our decimal place 1, 2 is going to be 20%. Simple as that, guys. Simple as that. Then for our C, what I need it. 45 cents of $3. Okay, now notice that we now have got different signs, we've got different units, so we have to use the same units. We have to change the units, okay? So we know that $1 is equal to 100 cents. So it's either we change the upper or the lower. I'm going to change the lower. So if we say $1, it's equals to 100 cents. Therefore, $3. Can I give us 3 is to 1 times 100 cents? Can I give us a 300 cents? Okay? So we move my sum here. Let's drop this off. So now we simplify. 45 cents over 300 cents times 100%. Okay, so we cancel out the senses. Cancel out the zeros. We divide 3 by 1. 3 by 1, 3. 1, remember 1, 3, 15, 5. So it's gonna be 15%. Thank you. Solution. Express the following percentages as functions in their lowest terms. In their lowest terms, okay? So it's gonna be A is a fraction is lowest term, 20 over 100. You cancel out the zeros, 20 to 1, 20 to 10, it's fine. That would be the lowest thing. Part B. 50%. It's gonna be half. I hope you're seeing what I'm doing. It will be the price of the blanket originally marked at $40. If he reduced, so we know that solution reduction of his price is fine, reduction by 12%, original price was marked at reduction by 12% original price. So what now is the price? The current price of the blanket. So we determine 12% of 40, cancel out 2 into 10, 5, 2 into 12, 6. 6 by 4 is 24, divided by 5, 5, 1, 5 into 24 is 4, remainder 4, into 4 is 8. So the price deduction, so 4.0, 4.80 is equivalent to 12% for the blanket. Okay, so now for us to determine the price of the blanket, now we're going to say $40 minus $4.80, and we get $35.20. So that would be the price. Okay, so this question requires us to determine the percentage increase. So we're going to say solution. The price of a suit is, let me just say old price, is $320. 4 months later, now this is the new price. It's now at $3. It's now at $335. What is now the percentage? Percentage increase. What is now the percentage increase? So we are going to subtract the 2 to obtain the percentage increase. 320, get 5, 1. So it increased by $15. So what was the percentage increase? We're going to say 15. Let me use another color. So percentage increase. The formula reads increase In our case, the original value is the old price times 100. So we are going to say 15 over 320 times 100. You can't out the rest. You can't out the zeros. 5, 2, 1. And then 1, 6, 2, 10, 2, 5, 15 by 5. So our value is going to be